Hello friends, I Professor Darshan Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for this subject head network theory. So friends, as far as our today's session is concerned, so we will try to discuss another basic example based on this system which we had started in last lecture, whose name is nothing but what? The mesh analysis. As I told you earlier, this is the analysis technique. Means what? Whenever it is required for we people to determine the current flowing through this desired branch, so at that time there are so many number of strategies by which we can analyze that AC or DC circuit. So this is one of the most important technique from network analysis point of view to determine all the branch currents or the current flowing through that any particular branch. The name given to that technique is nothing but what? The mesh analysis, right? So as you can see, the objective for our today's session is to what? We are in need of all branch currents which are present in this given network, right? By using the mesh analysis. So our objective is to determine the total number of branch currents involved in this given network by using the mesh analysis. So in that first step, what we need to do, we need to determine from sake of observation ki how many number of close conducting paths we used to have in this given network. That is nothing but what? We need to determine how many number of mesh we are having in that network. So basically mesh is nothing but what? It is nothing but one close conducting path which is present within that network, right? So we are coming on to this conclusion that there are two identical mesh, right? This is the first one and this is the second one. So there are two identical close conducting paths which are present within this network, which consists of the finite number of elements, right? Now elements in the sense we are having energy sources and these three basic electrical parameters: resistor, inductor and capacitor, right? So basically this example belongs to the type of DC network. So we don't have any energy storing devices like inductor and capacitor. Probably in a forthcoming session we will try to discuss such type of numericals in which we are having these energy storing devices like inductor as well as capacitor, right? So first of all we need to count that there are three resistive arm out of which one is 4 ohm, 6 ohm and 3 ohm, and there are two energy sources. One is what? A voltage source of 10 volt, and first time we are heading through this current source. This is the symbol of current source whose value is nothing but what? The 5 ampere. And what this arrow indicates here? This arrow indicates the direction of current belongs to this given current source which is nothing but what? The 5 ampere, right? Now the first step involves in case of this mesh analysis is nothing but what? We need to determine how many number of mesh we are having in that network. After that we need to apply this circuit analysis strategy, that is nothing but what? The Kirchhoff voltage law. According to this Kirchhoff voltage law, the algebraic sum of all ohmic drop equated to 0. The sum of all energy sources as well as each and every element belongs to that close conducting path equated to 0. That according to that Kirchhoff voltage law. Okay. Now as we are coming on to this conclusion, there are two identical mesh we are having with us. This is the first one and second one. Then immediately after that we need to assume the direction of currents belongs to mesh number 1 as well as mesh number 2, right? I1 belongs to fundamental current of mesh number 1 and I2 is nothing but what? The fundamental current belongs to the second close conducting branch or mesh number 2, that is nothing but what? I2. Then again how the direction of I1 as well as I2 are being considered? This is nothing but what? I1. The direction of I1 is also clockwise and the direction of I2 is also clockwise, right? Our objective is to what? We need to determine the all branch currents, right? So how many resistive arms we used to have in that circuitry? As we are having three resistive arms, this is 4 ohm of resistor, 3 ohm of resistor and this 6 ohm of resistor, right? So we need to determine current flowing through this 4 ohm of resistor, current flowing through this 3 ohm of resistor and current flowing through this 6 ohm of resistor. As far as this 4 ohm of resistor is concerned, so it belongs to mesh number 1. It has nothing to do with this I2. because it is not associated with this mesh number 2, right? It is connected or associated with mesh number 1. So which fundamental current flow through this 4 ohm of resistor? That is nothing but what? I1. What about I2? I2 is nothing but fundamental current belongs to mesh number 2. So current flowing through this 3 ohm of resistor is nothing but obviously I2, because again this 3 ohm resistor is associated with this mesh number 2. It has nothing to do with this mesh number 1, right? Now the last resistive arm is nothing but what? The 6 ohm of resistor. The 6 ohm of resistor is connected in vertical arm, means it is a part of mesh number 1 as well as mesh number 2, right? So this will be the third probable branch current flowing through this 6 ohm of resistor, right? Now, as we know, how this I1 flow through the 6 ohm of resistor, as the assumed direction of I1 is clockwise, means it flows from top to bottom, and at the same time the assumed direction for I2 is what? Again it is clockwise. But how this clockwise I2 current flow through the 6 ohm of resistor from bottom to top? Means we are coming on to this conclusion ki thus their circulating direction or the current flowing direction belongs to I1 and I2 are opposite to each other, right? So obviously the current flowing through this 6 ohm of resistor is nothing but what? I1 minus of I2, right? So first of all, what we need to do by using the basic strategy of this mesh analysis, we need to apply this Kirchhoff voltage law to that mesh number 1. When we apply that Kirchhoff voltage law to that mesh number 1, at that time we need to mark the polarity to this resistive arm according to the direction of assumed fundamental current. As the direction of I1 is clockwise, so how this I1 current flows through this 4 ohm of resistor which is connected in horizontal arm, right? So obviously current flows from this left hand side to right hand side, from left to right. Similarly, how this clockwise current flow through this vertical arm whose value is nothing but what? 6 ohm, from top to bottom. But through the 6 ohm resistor there will be a circulation of I1 as well as I2, right? So how I2 flow through the 6 ohm of resistor from bottom to top, right? So when we start our journey for this Kirchhoff voltage law, so we need to map the entire potential of this 10 volt of battery, right? This 10 volt of battery, how this battery is being mapped, as we are going from negative to positive plate. This smaller lead terminal is nothing but what? The negative plate, and the terminal whose length is larger is nothing but what? The positive plate. So as we are going from negative to positive, so the opposite sign we need to consider, so it will become plus 10, right? Then we need to consider the ohmic drop across this 4 ohm of resistor. So according to that Ohm's law, V equals to I into R. So as we know, which current flow through this 4 ohm of resistor? I1. The value of that resistor is what? 4, right? Then how this I1 flow through this 4 ohm of resistor from left to right? Means we need to follow the direction of assumed current, right? So while following the direction of assumed current, we are going from positive to negative plate. That's why its sign will become opposite. It will become negative. So it will become minus 4 times of I1, right? Then as far as the 6 ohm of resistor is concerned, so how I1 flow through the 6 ohm of resistor top to bottom, right? Means we are going from positive plate to negative plate. So opposite sign we need to consider. So minus 6 followed by I1 minus I2. Now question arises, why this minus sign is being taken into account within these two fundamental branch currents? Because their directions are opposite to each other. While considering the ohmic drop across the 6 ohm of resistor, when we apply the Kirchhoff voltage law to that mesh number 1, right? Now within that first mesh or within that first close conducting part, there are only 3 elements. One is 10 volt of batteries, 4 ohm of resistor and 6 ohm of resistor. So according to that KVL, the ohmic drops are being equated to 0, right? So after that we need to simplify basic mathematical manipulation we need to do. So 10 minus 4I1, this minus 6 will get multiplied with this parenthesis, so it will become minus 6I1 plus 6I2 equals to 0. So this equation will become minus 10I1 plus 6I2. This 10 is being shifted to the right hand side of this assignment operator, so it will become minus 10. This will be your equation number 1 for your mesh number 1, right? But what is the unique identity of this numerical key? We used to have this current source within that loop number 2. The value of that current source is how much? 5 ampere. And how this 5 ampere current flows through this mesh number 2? According to this current source, this 5 ampere current will flow in this direction, in anti-clockwise direction, right? But the assumed current is nothing but what? Clockwise direction. But according to the physical connection of this 5 ampere current source, which will try to push that 5 ampere of current in anti-clockwise direction, right? So as we know, this 5 ampere is nothing but what? The current belongs to mesh number 2. Means definitely we can say that here I2 itself is a minus 5 ampere. No need to apply the Kirchhoff voltage law to that mesh number 2, because directly we used to have one current source which is present within that mesh number 2, and according to its direction, this 5 ampere current flows in anti-clockwise direction, right? How the I2 is being considered? Clockwise, right? Here I2 itself is a 5 ampere of current, but I2 equals to minus 5. What this minus 5 sign indicates? That the assumed direction and the actual directions are opposite to each other. That's why the negative sign is being taken into account, right? Then in order to determine the branch current, when we equate this desired value of I2 into that equation number 1, so we are getting I1 minus 10 times of I1 plus 6 into I2 is nothing but what? Minus 5 equals to minus 10. So obviously it will become minus 10 times of I1, 6 5s are 30, minus 30 equals to minus 10 here, right? This is how our equation number 1 will become after substituting I2 equals to minus 5 according to the given current source which is present in that network, right? Then again when we simplify this statement, so it will become minus 10 I1, this minus 30 is being shifted to the right hand side of this assignment operator, so it will become plus 30, right? So plus 30 minus 10 means it will become 20, right? So I1 equals to what here? Minus 20 by 10. 10 to the 20 minus 2 ampere is nothing but what? Our I1, right? So this I1 is nothing but what? The first branch current in suffix later. This will be I1, right? The second branch current I2 is nothing but what? This fundamental current I2 itself is the second branch current which exactly equals to minus 5 ampere. What was our objective? We are supposed to determine all branch currents. So as there are 3 resistive arms, this 4 ohm of resistor, which current flow through this 4 ohm of resistor? I1, that is nothing but what? Minus 2 ampere, right? What about this 3 ohm of resistor? Clearly this 5 ampere of current flows through this 3 ohm of resistor, whose value is nothing but what? According to its connection, it is minus 5. Now it's time to determine the current flowing through this 6 ohm of resistor, right? Now which current flow through this 6 ohm of resistor? I1 minus of I2, because their direction of currents are opposite to each other, right? So here in this suffix letter I3 equals to I1 minus I2. I1 equals to what here? I1 equals to minus 2 ampere. This minus I2 equals to minus 5 ampere. So obviously this minus minus will become plus. So it will become minus 2 plus 5. So obviously I3 current flowing through this 6 ohm of resistor, it will become 3 ampere, right? So in this way all the branch currents are being tabulated by using this mesh analysis technique. The only difference as compared to the previous session example is, in this example or in this network we used to have that current source which is present within that mesh number 2, which represents the fundamental current belongs to mesh number 2. So this is how all the branch currents are being tabulated. Thank you.